And we're live, folks. So I want to give you a quick reminder of the what we covered on Tuesday, which was that when we're factorizing, which remember means going from an expression to a product, things multiplied together. When we're factorizing, there is an order to the factorized. There is a sequence that we follow through in our head. So we start off with highest common factor. And then we ask ourselves, is it a perfect square or dots? Which one's that one? Other way around. Yeah, so that's dots. So for a dots, you're looking at just two terms, and each of those terms is a perfect square. So this one is 3x squared. This one is, I should have put a y there, sorry, it's not there, is 4y, which is then all squared. So 3x all squared minus 4y all squared. So as soon as it's got two terms, ask yourself if it's a dots. Perfect square is this one here. This is 5x all squared. This is 4 all squared. And remember what we do. We double it. So we mush them together. So 4 times 5 is 20. And double it to get 40. And therefore, it's a perfect square. Now, if you're not used to doing this, it's going to feel like wading through molasses to start with. You're going to feel like, oh my gosh, it's taking me ages to even work out whether it is a perfect square. How about I just use a simpler method? But remember what I said on Tuesday? When you lean into the simpler methods, you end up hamstringing yourself for future mathematics. Okay, because you can't always keep going back to basic stuff. You need to get a handle on the pattern recognition so that you can just do that with ease and handle harder maths. Have your brain working on the harder maths, not the easier stuff. And it is easy. Honestly, it is easy. It's just, if it feels hard, it's because of lack of practice only. I really believe in that. And then, I'm sorry, it's a little bit off the screen there, but there's a grouping example down there as well. So you'll notice that, I didn't talk about monic, non-monic. If it's not a perfect square, if it's not a dots, you might be able to factorize using what's called monic factorization. And that's when there's nothing before the x squared, or non-monic factorization, which means there's something before the x squared, like the 12 here. We will go through these methods. You've probably done at least monic factorization in grade 9 maths, maybe? I don't know. Yeah, maybe? I don't know. We'll go through it anyway. I like going through things anyway. It doesn't hurt for you to go through things again. It's just the speed through which I go it. If you've seen it before, I'll go through it quickly. If you've never seen it, I just slow down a bit. So that's how I make a change there. And then the last one is grouping. I should say, just for completeness sake, this is also a non-monic because there's a 3 in front of the x squared. This is also a non-monic because there's a 25 in front of the x squared. They are non-monic, but I wouldn't use a non-monic factorization. I would use the perfect square. So, language is a bit fraught here. Non-monic actually just describes a trinomial, 3 terms, where you've got something in front of the x squared term that's other than 1. That's what makes it non-monic. So technically this is a non-monic, but when I refer to it here, I'm saying using a special trinomial factorization technique, whereas this is a special rule. Okay, so I'm going to pause the video in a second because I've got an in-class activity to do. And if you're watching this from home because you aren't here in class, then I'll attach it to the post with this video. But what I'm going to do, I left it somewhere, is I'm going to hand out a sheet. Excuse me, sorry. And the sheet has a long list of different kinds of expressions. And what you need to do is you need to figure out what kind of factorization is required to be done. You do not need to solve a single problem. What you need to do is just write next to each problem HCF or PS for perfect square, or dots, or monic, or non-monic if you think it might be, but you don't know those well enough yet, but have a guess at it, or grouping. By the way, the pattern for grouping is if there are 4 terms, that's when grouping might work. And don't forget, there's a default as well, which is maybe nothing works. Maybe it can't be factorized. Like, for example, x squared plus 1 cannot be factorized any more than it is. So there's always that as a thing as well, not factorized at all. So use these terms here that I've got on the board here. So HCF, PS, or DOTS, monic, non-monic, or grouping, or none. It may be that some of them require more than one. So it might be HCF, then DOTS. Yeah? So you need to think about it really carefully. There's a whole bunch of them, and I'm going to give you 10 minutes at most, less if you get through it faster, but 10 minutes at most to categorize. There's about 30 of them. And again, you're not solving them, you're not actually factorizing them, you're just categorizing them, because that's the true skill to start with. Can you recognize what it is? Now, this is not a test, so I'd like you to work, you don't have to, but I'd like you to work with one or two others if you can and figure it out together. You could do that by saying everyone do 10 in your group of 3, or you could actually just figure them out together really quickly because you've got a second pair of eyes looking at them. It's up to you. If you choose to work alone, that's fine, but working with someone else is probably going to be faster for you. Right, I'll pause the video.